Jersey, your solar energy IQ is brilliant. And if you know why several thousand huge mirrors are splayed across the Mojave Desert in California, consider yourself a solar energy genius.
Every single day when the sun comes up, we are bathed with enough energy in one day to supply all the power we need for 5 years across the globe.
Are you really doing it this way?
Lyle Rawlings has been making a living off that fact for 25 years. He's known as the godfather of solar in New Jersey. His company's installation of solar panels on this warehouse roof will provide 90% of the facility's power. But the technology doesn't come cheap.
Solar power is more expensive than fossil fuel power. So our business actually depends on government subsidies.
So does the oil business and the coal business, the nuclear industry too. But the outlook for solar power is brighter than any of those established technologies. General Electric estimates its solar energy division will bring in more than $1 billion in annual revenue in 3 years. JP Morgan Chase and Wells Fargo are investors in the biggest solar plant built in a generation.
Solar is the one technology that is decreasing in price, increasing in opportunity, and can become a key part of the solution if we make the right strategic investments today.
Which brings us back to those mirrors in the Mojave Desert. No less a cutting-edge giant than Google is heavily invested in similar technology for turning sunlight into power. Betting, just as is New Jersey's godfather of solar, that this country must build a vibrant solar industry before oil and coal run out.
For us in the solar industry, the holy grail is the point at which the cost of solar power is about equal to the cost of fossil fuel power.
Experts say that should happen in 7 to 10 years, and by 2025, one report concludes,
Engineering TV is sponsored by DigiKey.
Terry Knight with Engineering TV, here with Adrian Valenzuela. He's with Texas Instruments as a product manager, going to tell us about ultra-low power microprocessors. Well, Adrian, show us what you got here. Here we have a huge array.
Well, it's almost done. Are you the timekeeper? No? You'll let me know when it's time to leave? When I see you get up and walk out, then I know it's time to go. I need to put on a mic, right? I better put this on. Can you hear me in Idaho Falls?
Yeah, we can hear you.
Is someone there taking roll for you guys up there?
I saw Todd out in the parking lot, so I'm guessing he'll be here in a second.
Okay, welcome. Welcome to Engineering 120. The good news is you're in the right classroom. Bad news is we have today and 4 more days together. Sorry. Okay. The attendance sheet is being passed around. Make sure you sign that for the EE portion, electrical engineering portion of this course. On the Elmo here, if we could see that on the overhead. There's basically 4 things that's going to determine your grade of the EE portion, okay? And so this is like falling off a log, almost, as long as you're here. This course is not very demanding mathematically or otherwise, and so attendance is the easiest thing to measure, the easiest thing to determine the grade. So number 4 item, be Item number 3, question. I would like all of you to email me a particular question. You don't have to do it this week, next week, but sometime over the next 3 weeks. Some question you have that you'd like a little more information on, a topic or something about electrical engineering. Understand that I know that none of you are necessarily plan on being electrical engineers. That's okay. But I'd like you to email back to me a particular question. And then what I'm going to try to do over the next several times we meet is group those in together and at least try to address some of that interest that you have. Okay? Item number 2. As a final exercise in this course, we'd like you to pretend, if you will, and you can even practice this if you like with your friends, but prepare a 10 to 15 minute PowerPoint presentation, if you will, and turn that PowerPoint presentation into me. We won't have the opportunity to actually give it, but prepare it as if you were going to give it, okay? So 10 to 15 slides on a topic of your choice that pertains to electrical engineering. Okay? And then item number 1 is at the end of each week, I'd like you to email to me a summary, basically a 1-page or less email summary of what we did for the week and what you learned, what thoughts you had. Okay? Questions?
Yeah, for the PowerPoint, do you want us emailed to you?
It can come any way you want to give it. With our new email system, space is not a problem, which was in the past, your inbox would fill up. So whatever's convenient to you. You can email it or bring it in physical hard copy. When are those PowerPoints due? Good question. When are they due? They'll probably be due because our class goes through a dead week. So we'll make it due the last period, the last time we meet. Okay? Otherwise, we get into finals week. Question? Yes. Yes. So this week, you'll summarize what Dr. Mosavinajad and others presented last Monday and what takes place today. Okay? Got another question?
Yeah. So, is there a specific way you want us for the summary? A specific way to write the summary there?
I mean as far as the format goes? No particular format. You can just embed it within an email. Just send me an email. In line with the email, just, spill out your soul for the week, If you want to be more formal and write it up and then attach a document, that's fine too, but, okay? Good question. Like today's Wednesday, so yes, let's have them, due Friday or earlier, Whenever you're doing summaries like this, of course, after you're done with this, you don't have any classes you're going to, so you take 15 minutes and you write down your thoughts while they're still fresh. But let's have the summaries due, beginning of day on Friday. So you have Wednesday night and Thursday night to think about it before it gets too old. Okay? Any questions from Idle Falls? Any questions from our overflow room? What's that, room 16? Is there any way to see them from now and again? Okay, so who wants to be my checker to go make sure they're awake in there? Did the sign-up sheet get passed around? Has it made it all the way around yet? Not yet? Okay. Okay, any questions before we begin? could I just kind of like to see kind of the mix? How many here are thinking about mechanical engineering? So about 35.5%. Yeah. All right. Civil engineering, about 24.5. Nuclear, about the same. Computer science, is that one? Okay. And then anybody else who didn't raise your hand? Okay, so how many could be convinced to be electrical engineering? So all the rest of you guys I'm going to ignore. I'm just going to focus on these two right here. Okay. Okay. No questions. All right. So that make it around? Okay. Uh-oh. Since you're standing up, will you put your name on this and then take it to room 16? What's your name? What is it? Yeah, you know where 16 is? Thank you. You know, I try not to be real hard on the people that are late, because oftentimes there's times when something happens, flat tires and who knows what. Particularly in the winter time, you know, you go out and your car battery's dead and that sort of thing. But it's just invariably you just cover everything like this, and then, you know, somebody walks in and what do? Okay, I'm looking for my notes. Who took them? All right, here they are. All right. Part of what I am going to endeavor to cover over the next few days, and I won't be the only face up here that you're going to see, but if you see me, then you know that I haven't been successful getting somebody else to come here and visit with you, okay? So feel sorry for me if you see me, okay? All right. So, but we're gonna try to introduce you, or I'm gonna try to introduce you to various topics or ideas or areas that have to do with electrical engineering. And so, on the Elmo here, this is kind of representative of things that's on our mind. And alternative energy. And by the way, any of these topics, you know, in your presentation you're going to be putting together and thinking about, you know, they're all fair. Okay, so a lot of interest these days about alternative energy. Is there anybody here who already has an alternative energy device at their home or a parent's home, or you've seen it at a friend's home? Okay. Basically, we're talking about, you know, capturing energy from almost wherever we can get it. Why? Well, partly because it's a challenge. Secondly, once you start paying the bills and you have to pay for your energy needs, you're always looking around for a better way to do things with less money and, you know, better whatever. And so, of course, this is representative of talking about either solar, if I can speak, solar panels using photovoltaic process where light energy is converted to electrical energy. That's actually a pretty interesting idea. And actually, it's kind of new for us in modern ways, because this technology is based upon using silicon. And silicon is an element that is commonly found in sand, but it has to be refined and made very pure in order to be effective, in order to convert light energy to electricity. Who can think of another process that exists in nature that also converts light energy to some other form of energy? Photosynthesis. So Mother Nature has been at this for a long time. It's too bad that our skin doesn't do that. We could walk around and recharge ourselves, kind of like. But I mean, people are making batteries, if you will, or solar cells, I should say, that fit on backpacks, on clothes, on hats. So as you do walk around, you can be charging up some of your electronic devices. So then, of course, another is wind energy. Wind energy is, thought to be popular around here because the wind blows once or twice a year. Right? Think so? I mean, Pocatello is a relatively windy place. What would really be nice is when the wind really does blow, because, I mean, there's a few days when it blows really hard, that you could capture a whole bunch of energy on those days and then save it, because there's lots of days where it's pretty calm. So, of course, that's the downside of wind energy, is that it only comes when the wind blows. Now, there's other kinds of devices for increasing energy or capturing energy. Anybody have any idea what some of those might be?
Using dams with water flow.
Yeah, using dams to create the water to do that. And there's a lot of interest in micro water turbines. Like at my place, I live out north of town a little bit, kind of a farming area, so during the summertime there's a lot of irrigation water that flows over, small dams, this and that. And oftentimes there'll be a head of maybe 8 feet that a pretty good stream of water flows over. I thought, boy, we ought to be putting a little, micro generators in there and capturing some of that energy. Question?
Did you also say increases energy?
Well, it allows us to capture, other devices allows us to capture energy. There's wind, there's light.
Yeah, that's what I was asking. If that's what you're asking us for, is also items that increase energy.
Do you have an idea or?
Yeah, I was just going to say, like, there's alternators, there's, I can't remember what they're called, but in power plants they have devices that increase or decrease the amount of electrical energy that's being put out, and they have them on power poles before they get to your house. And they have tons of devices that increase or decrease energy, and tons of devices that create energy right now.
Okay. If you live near the sea, there's people who are thinking about using tidal forces, tidal waves, or the movement of water from dew to tide in order to, generate electricity. And of course, there's traditional methods as well. In this, there's usually a device here called a charge controller, which is an electronic device, and this is where electrical engineering comes into play in a big part. Of course, electrical engineers are designing the process and understand electricity here. This is probably mostly a mechanical job on a windmill, but you have a generator, which is an electrical job. But the charge controller is an electronic device that takes the energy that exists in the form of direct current and then either changes it to work with alternating current, so it works with your home or business, or uses it to charge up batteries or whatever you need to do. And this is a very electrical engineering type component here. And so this particular diagram here is showing that you come here with the charge controller, then you hook into your electrical panel, and it participates with the utility in powering your laptop, your light, as well as your refrigerator, if you will. So anyhow, we'll talk about this as we have time. Alternative energy, a big topic, a lot of fun to think about. Me personally, this last year, I invested in an electric scooter. So I ride to and from work. It's kind of cold right now, so I'm kind of, waiting for warm weather to come. But I charge the scooter up at night in the garage, and it takes a couple hours. And I have a little meter on there that tells me how many kilowatt hours I use to charge up the scooter, and it costs me maybe 2 kilowatt hours every night. And that's for a 15-mile round trip. So how much do we pay for a kilowatt hour of electricity here in Idaho? Anybody know?
6.5 cents.
It kind of depends on the time of year, whether it's summer or winter, but 6.5, 7 cents in that neighborhood. So for me to come to work and go back in a day, it's about a 15-cent trip. Not bad. Okay. All right. Okay, some other things about electrical engineering. Try to get it. There we go. I guess I could look at it on my thing. All right. These are different topics, and sometimes they represent different disciplines or opportunities. Most of the time, these kind of topics are different areas of focus that electrical engineers study. And as you go out and actually practice in a job, you probably still apply a lot of these concepts, but maybe don't become expert in them, depending upon what your job is. But at the top of the list of the electrical engineer is a circuit analysis. Kind of like if you're a plumber, you got to understand pipes. But basically, circuit analysis is understanding how to design and build and configure electrical devices to accomplish what you need. And so you need to talk about volts and amps and resistance. And I assume that most of you have been through physics a little bit. And so you have a basic idea as to what those terms are. And we'll talk about this just a little bit in another time, a little more depth. But this is a real nuts and bolts, and there's a couple of classes that are taught just dealing with how to analyze circuits and how to configure to do what you need them to do. Probably, in my opinion, the second next most important topic for electrical engineering, and probably for almost any engineering, is called electromagnetics. And the challenge in this particular course is a couple of things. One is you're studying something that you have never seen and will never see. You could only determine its existence by means of instrumentation or other things. Who's ever seen an electron? I mean, if you've played with a magnet, which is a natural device, it could be a natural device. I mean, you can feel the pull, the attraction, but you don't see the lines of force, if you will, that make up that connection. But electromagnetics drives a lot of what happens in electrical engineering, from the distribution of power from a power company, using motors, or generators or alternators. It gets used in cell phones on the high frequency end of electromagnetic propagation through radio waves. Gets used in laser printers, copiers that use electrostatic principles. So it's kind of real fundamental science behind a lot of the latest things that happen in electrical engineering. The solid state electronics is where all of us benefit through the advances of using microcircuits. Not too many years ago, Of course, before you were here and even, before I was here, circuits were very much different. They were very large. They even had devices called vacuum tubes in them, which were very large and used a lot of energy to make them work. But over the years, we have learned how to package circuits into solid-state devices. And what does this mean? It basically means that we take silicon, which is an element, and we purify it, and we present it in a pure crystalline form. So it's a very regular crystal type structure with a lattice and element, and the atoms are fixed in a regular position with each other. And then very carefully introduce, and by the way, silicon in its pure form is what they call a semiconductor. And well, they call it a semiconductor because naturally it does not conduct. I mean, it's an insulator. It's like glass or quartz. But they have learned over the years that if they can introduce a little bit of impurities, other elements such as arsenic or boron, they can introduce these impurities in the proper place in the proper amount in order to get the circuit to conduct. And through the solid-state electronics, which is what ON Semiconductor does, which is on top of the hill up here, as well as Intel, they're able to make very tiny circuits. I mean, transistors that are a millionth of an inch in dimension. And thereby, you can have a computer that sits on your desk or that you can carry as, as a laptop or as a cell phone or a lot of other things. Otherwise, it'd be impossible. But we can put millions of these computing devices on a small silicon chip through solid-state electronics. And so the advances over the last 50 years in electrical engineering, which we all benefit from, is really attributed to the miniaturization, if you will, of solid-state electronics, in my opinion. But of course, the next two items would never have been possible. Well, anything I mentioned up front wouldn't have been possible if we didn't have people that understood how to generate electrical energy. Who was the first person to, well, I guess somewhat the first person to generate electricity and do something useful with it? Anybody? I mean, generally attributed to Thomas Edison. What was he inventing? I mean, the light bulb. You turn on the light in the morning, you probably don't think how difficult that was at the time when there wasn't no light. So, he probably had the light bulb, then he had to figure out, how do I power this thing? And so that spawned, the science or the delving into how to do that. So, energy, electrical energy. So when was Edison alive in 18 what? What era? 1850, about 1870, 1880. So from about 1850 to 1880, was kind of the 50 years of developing. Okay, how are we going to develop electrical power and distribute it to people? And so some started doing it with DC systems, some started doing it with AC, alternating current systems, and then for the most part, alternating current systems became the prevalent way of distributing electrical power. So nowadays, we pretty much depend upon it and expect it to be there. And we don't really understand or appreciate how that source of energy has improved our lives. Anybody remember back in grade school or junior high maybe when you're studying simple machines? Anybody remember an example of a simple machine? Like a lever? What's an example of something you use that has a lever on it? Or maybe you don't use. I think of a wheelbarrow. Okay. So a wheelbarrow has two simple machines actually. It has the lever for leverage, and then it has the wheels so you can move it in the rolls and that sort of thing. Okay. Screwdriver, be that. I mean, the screw itself is an inclined plane, that drives the screw in. It's not a slant, so it drives it down. So anyhow, a simple machine gives you mechanical advantage. You, the operator, you can lift more because you have the mechanical advantage of a lever. But the energy is the same. You provide the same amount of energy. It's just that, using a lever, you have to go through a greater distance. But it's the same energy, but it's possible because it matches your ability and that sort of thing, okay? So simple machines have been around for a long time, from the beginning of time up until 1850 or so. But what happened when electrical energy became available? Then you took a simple machine and it was amplified by an external energy source. So now, for example, a bicycle is an example of a simple machine. It's something that you can ride, and it has gearing on it to make it easier to go up the hills and down and that sort of thing. But you provided all the energy to make it go. But now, with an additional energy source, you can sit in an automobile. And it's not just applying a simple machine anymore, because you can just turn a key a little bit and push on a pedal a little bit, and you can go pretty fast down the road. So your efforts are being multiplied thousands of times by the addition of an external energy source. And so this is what's happened in our age, and that's why we can go about do more, is because we're able to leverage an additional energy source. But anyhow, electric machines, electrical power systems, this is the big part of electrical engineering, either in the production side or in the building design side for your homes as far as using electrical energy. There's other energy sources besides electrical energy, of course. There's natural gas, and there's nuclear, there's coal. And we mentioned the sun already. So there's some that envision what's called a hydrogen economy, where you take a nuclear reactor, instead of using the nuclear reactor to produce electrical energy, you use the nuclear reactor to create hydrogen, produce hydrogen. Then you use that hydrogen for your energy, which could be, like an automobile, for motion, or then for, creating electricity if you need it for electricity, so forth. Okay, anyhow, a lot going on in the energy world. Okay, another area of electrical engineering is digital logic circuits. And this area really has to do with computers. And digital logic circuits is a, kind of a science and a math in and of itself. Understanding how to go about creating the circuits in order to, do some logic function. And, the most common logic functions we have nowadays is computers. But it could be watches, computers, could be all kinds of gadgets. Using Boolean logic. And ultimately, all of these digital circuits also evolve down to what we call analog. But it's really helpful when we can get above the analog, because that's rather complex, and just deal with ones and zeros. And so digital logic circuits, computer systems go hand in hand in their application. In the world of inventions, if you will, you can't really say that any one person invented the computer, but as a society, the invention or the use of the computer, to me, is kind of unique in the world of inventions. We mentioned Thomas Edison's electric light bulb as an invention, and there's the automobile, of course. A lot of these inventions involve understanding a physical property or characteristic of some function, an element, or this or that, and creating a gadget or thing to, take advantage of it. But usually involves some, physical phenomena that somebody observed and discovered, and then that's the invention. The computer, on the other hand, I think is unique because the computer is a figment of our imagination. I mean, it really exists only in how we think it does exist. And the creation of the computer and the organization, how to go about multiplying, how to do this, how to do that, or just different ways that people thought how to do it. So it's not really harnessing a particular idea or physical phenomena per se, but it's kind of a sum creation of a lot of our creativity, which I think makes it kind of unique in terms of inventions, and I think that's kind of why it's maybe easier for the younger generation to grasp computer ideas because it's just natural. If you're intelligent, which you guys are, oh, this makes sense. Do it this way. That sort of thing. Okay, moving on. Communication systems. There's been a need to communicate for a long time. It wasn't too long ago that if you wanted to send a message from one city to the next city, how did you send that message? You by horse. Yeah, by horse. Now, some of the Native Americans maybe had a little better. They could do smoke signals out on the, the mountain ridge or something like that, or drums or whatever to convey a message. But for the most part, if we had a message that had to be sent, it had to go by horse. So the Pony Express was our messaging system, the last one that ran by horse. And that ran up into, 1865 or so? How many days did it take to go from, like, I don't know where it go, from St. Louis somewhere to San Francisco? Maybe 7-day trip or something, by horse. Of course, not the same horse or the same rider. So, a big need to communicate. So how do we communicate nowadays? Go by horse, right? Okay, so, anybody communicate with anybody today? Outside your, of course we talk like that, we're communicating, but anybody call anybody on the phone? So how does it work? Anybody use a cell phone this morning? Oh, we all did. Okay. Okay, so, how does a cell phone work? Question in the back.
I just think it's funny that we take communication for granted a lot nowadays. When I remember when I was just a child, which wasn't that long ago, and it feels like everybody was talking about, oh, wouldn't it be so neat if you could just send a holographic, and people could see you and talk to you, like on Star Trek or something. And now we have that almost completely. We don't have a virtual holographic, showing of that person, but that's basically what we have nowadays. You can send instantly almost anywhere by phone or by other instrument and see that person's face, see what's going on around them, have them talk to you, and know what's going on like instantly on the other side of the world.
Yeah, it's, and I don't suspect that the pace is going to let up. But I have a son that's back in Wisconsin going to school, and every Sunday we get on Skype, and he gets on Skype, and we, can share. This would have been unthought of just even a few years ago. And of course, that's going over the internet, which is a great means of communication nowadays, which involves email and Facebook and all this other kind of stuff. But, YouTube, just lots of opportunity to communicate and share ideas. And most of these are made possible through the studies and efforts of electrical engineers and communication systems. So if it's computer communications, that usually sometimes takes place over wires, but you also have places where you have to go from place to place, and there's no wires. How do we do this? Well, we do it through electromagnetic communication, which could be microwave, satellite, or like a cell phone. I mean, it has radio towers, and so you have electromagnetic communication, these waves that, operate between the two. And we don't see, well, we don't see it. But you take electromagnetic radiation, for example, which is part of this electromagnetics thing I was talking about. The people who were studying electromagnetics in the 1850s, they didn't have the equipment or the ability to create electromagnetic waves, but just through the math and the properties of what they're doing and going through, they predicted that there are and would be, or could be, if you will, electromagnetic waves. And so it took another couple of decades before somebody actually found a way to create these electromagnetic waves, and the first ability to use those and demonstrate that they work was communication across the Atlantic from New York to London or Paris or somewhere. And that was, turn of the century, 1900, type time frame. So, I mean, just lots of advances in communication systems. Okay, another kind of related to that, electro-optics. A lot of communications are handled also through optical paths on fiber optics. Sprint network, years and years ago, they buried a lot of fiber optic networks along the railroad tracks, right-of-ways, in between major, cities and things like that. And those became very important, backbones for communications of voice and data and computers and everything else, long before people thought about internet stuff. So you have electro-optics communication, fiber optic stuff. Another big area is in the area of instrumentation. If you're studying a phenomena or learning about something or running a plant of some sort and you want your process to run properly, then there's the instrumentation to measure temperature, measure time, measure speed, velocity, whatever it is you need to measure, and then use that to control your process. And so our ability to control processes either for safety or product quality has improved vastly over the years, but this is the realm of instrumentation. And then kind of a cousin to instrumentation is a control system which is using like information that the instrumentation system gathers up and then making intelligent decisions about what do we do, how do we control, how do we improve the process, the flow, the quality, how do we ensure that we have the security there. And so there's control systems to control everything. Now the control used to be thought of a speed control on an automobile. Who here has driven an automobile that does not have cruise control? You really have a car that doesn't have cruise control? Oh, it broke. Well, sorry. It's hard to find one nowadays without cruise control. And that used to be, oh, what a luxury, You just put it on there, take your foot off, and relax. But now cruise control is very common. How many here are running in model airplanes or cars or remote control? I mean, you've done some of the toy things, right? So, if you read in the news, as far as military applications go, a lot of interest on remote flying, if you will, of military hardware. It could be a tank, it could be an airplane, it could be a variety of things. And there's a lot of controls, a lot of communications, a lot of other things that go into that to make that work. But that's something that's come about in the last several years, is our ability to control things remotely or safely through robotics in order to fly airplanes or drive cars or whatever. There's a contest somewhere in Southern California that's all the automobiles, and it's going across the desert area, whatnot, are all self-autonomous. actually no pilots, no drivers, not even remotely. I mean, the car on its own is making its own decision, just traversing the path, if you can imagine. So, lots of interesting things going on. Okay. So, I mean, there should be a lot to talk about in your PowerPoint deal. If you just take something that we're familiar with, like the automobile over the last 10 years went through a great transformation. Over the next 10 years, it's going to even do a greater transformation, because all of these topics or functions of an automobile have to do with electrical systems. But they do not include, in this case, well, over here on the powertrain, I mean, the engine of choice over the last decades in terms of an automobile is a internal combustion engine. And that has changed to some degree. There's hybrid vehicles out there. There's electric, and there'll be even more electric vehicles out there. And so the engine and transmission, instead of electronics controlling those mechanical devices, they're going to be largely electrical devices. But of course, there still need to be a lot of mechanical engineers involved in those things to make sure that they handle the structural and the mechanical aspects. But you have, and this charging is, of course, a real huge deal. Charging, battery management, if you're talking about a hybrid or electrical vehicle, is a big deal. Cooling fans will take on a little different flavor. Ignition may be a thing of the past. That sort of thing. This electric scooter I have, I mean, it's kind of cool. You turn the key on. You don't have a Kickstarter or anything else beyond that. You just turn the key on, you go. There isn't anything to ignite. There isn't anything to go otherwise. Other things, of course, the entertainment. This is what you guys are all involved with. Of course, cell phones, no big deal. A lot of people buy a car based upon its sound system. You guys wouldn't do that. I mean, you go get your favorite tunes, you go sit out in your car to listen to it because that's the best sound system you got in your whole world, right? And of course, video, that's only if you have younger kids that you're trying to entertain. Radio, how's radio different now than it used to be? Maybe you don't know how it was used to be. But satellite radio, how's that different from terrestrial radio, I guess? I mean, old style radio, you depended upon, radio transmission over here to somehow reach you over here, over mountain or vale or whatever. And as you moved around, you'd lose it or come in, particularly at night. You get a lot more choice of stations because the atmosphere is more quiet, not as noisy, and so you can get more. But now from satellite, you can pretty much go everywhere uninterrupted on your favorite station. And here's one kind of watching a little bit. Not sure where this is actually going to go, but I've seen, or at least read about, Wi-Fi hotspots within your car itself. So how would that be? I mean, you're on your BlackBerry or your whatever, accessing the web. You're in your car. It's providing a hotspot so you can get on the internet wherever you're at. You don't have to go to the coffee shop or somewhere else. So a lot of things going on. Okay. Any questions, comments? Okay. If not, maybe we'll. This is not really a razzle-dazzle kind of thing, but this is a site called engineeringtv.com. And I was just looking at something that I could share, and I'm looking to where they have the archives. Somebody moved it on me. But
array of ultra low power demos.
I mean, this is kind of fun.
Central to the energy harvesting world is ultra low power processing. So we have dedicated product lines within the embedded processing that target specifically the ultra low power space. Central to that is the MSP430 that was designed from the ground up about 15 years ago, 20 years ago, specifically for ultra low power consumption. So if you look around the show today, or even some of the demos I have here, we have embedded processing, so small MCUs paired usually with some sort of radio that consume very low power and can be powered from harvested energy, which is the focus of the show here today.
And what do you mean ultra low power?
In the case of MCUs, you typically measure that a couple of different ways. You can measure that in active power, you can measure that in standby power, you usually measure sometimes the current consumption of the peripherals. For a typical MSP430, when you're in standby mode,
we'll see you not next Monday, a week from Monday, right? Hope I don't see any of you next Monday.